Okay, hello everybody. So today we're going to continue our discussion in Chapter 5, Section 5. And as you hopefully know from the previous video, we were discussing how to solve absolute value inequalities. We're going to continue our discussion today with that. However, I'm going to show you how to use absolute value inequalities to solve certain types of word problems. And so as you can see for number 4, this is an example of that. We have a person named Ginger who is playing golf, and Ginger's score was within 5 strokes of her normal average score of 52. We want to determine the range of scores for her current game that she got. And so the first thing that we're going to do is we're going to define a variable, and we're going to call x the score that Ginger got. So we'll say Ginger's, that's her actual score that she just shot the last time she was on the golf course. And so what it says is her actual score that she got was within 5 strokes of her average, which is a 52. So here's how we arrange that. What we do is we take the absolute value, and then we take her current score, and we subtract away 52, because when you subtract two numbers, that gives you the difference or the distance in between those numbers. And what it says is that it was within 5 strokes of her average. So that means the difference of her score that she got and her average was less than or equal to 5 strokes. So now we've established what the absolute value inequality is, and we just need to solve it. And the way that you solve those, remember, they break into 2 parts. So the first part is you just drop the absolute value and you solve the inequality like you would any other inequality. The second way is you keep what is inside, you flip the sign over, and you make the number outside of the absolute values negative. And so in solving this, we're going to add 52 to both sides. And when I do that, you see I get x is less than or equal to 57. Now this one, when I add 52 to both sides, I get x is greater than or equal to 47. And so now we have two inequalities, but these two inequalities can actually be combined into one, because when I flip this second one around, I get 47 is less than or equal to x, but then this says x is less than or equal to 57, like that. And so by combining those two, we get a compound inequality that we've studied in previous sections. And that compound inequality gives us a range of scores that Ginger would have gotten on her last golf game. In this case, the lowest that she could have scored would have been a 47, and the greatest she could have scored was a 57. And remember, in golf, the lower the number, the better. So hopefully she scored 47 or close to that. Okay, so number 5 is going to be solved very similarly. It says the weatherman predicted that the temperature would be within 9 degrees of 78 degrees Fahrenheit. It says find the range of temperatures. So the first thing that we're going to do is we're going to call x is the actual temperature, because we don't know what the temperature is, but we do know that the temperature is within 9 degrees of 78. So then I'm going to set up my inequality. So it's going to be the absolute value of x, and then the spread between x and the average temperature is 78 degrees. And we do know that it should be less than or equal to 9. So whatever the temperature is, minus the predicted temperature of 78, there will be not more than a 9-degree difference between those two. And so now it's just a matter of solving those by splitting them into two inequalities like we did in the last problem. So you have x minus 78 is less than or equal to 9. And then we would have x minus 78 is greater than or equal to negative 9. Now solving those, you would add 78 to both sides. And I would get x is less than or equal to 87. Now this one, I would also add 78 to both sides. and I would get x is greater than or equal to 69. And so now I have two answers. My two answers say that x has to be less than or equal to 87, or it has to be greater than or equal to 69. And when I take this x is greater than or equal to 69 and I flip it around, I get 69 is less than or equal to x. But then this says x is less than or equal to 87. And you can see what I end up with is another compound inequality. This is an and inequality. And you can see that that x is going to be sandwiched in between the two numbers 69 and 87. Therefore, the temperature range for that day can be anywhere from 69 degrees all the way up to 87 degrees. So that's a pretty big range of temperature, actually, to be off that much. Usually the weathermen are a little bit closer. All right, so this one says solve and graph the absolute value. So this isn't writing any inequality or anything. We just want to solve and graph it. So we will start out by splitting this into two, just like we did in the last one. And then we're going to proceed to solve this by adding 5 to both sides. So we get 2g is greater than or equal to 14. And then 2g is less than or equal to 14. And I did goof this up because this should have been, when you flip the sign over, you have to make the 9 a negative. So that should have been negative 9 plus 5. And negative 9 plus 5 is negative 4. So there I caught my mistake. So don't forget, when you flip the sign over, you also make the other number negative on the outside. Now we're going to divide both sides by 2 on both of the equations, and we get g is greater than or equal to 7, or we get g is less than or equal to negative 4. Now in this case, this one would not be one that you could combine, and here's why. When I go to graph this, if you were to look at the graph of this, if here is negative 4, and then there's negative 5, and we'll call this negative 6. And then 3, 2, 1, 0. 1, 2, 3, 4, 5, 6, 7. Call that 7. Here's 8. I'm not going to put all the numbers in. But if I were to go and now graph this, when g is greater than or equal to 7, that would be a solid dot on 7, and it's shaded to the right. The other one, g is less than or equal to negative 4, that would be a solid dot on negative 4, but it would be shaded over here. And if you remember, when we studied compound inequalities, when you have an inequality graph that has the ends shaded, but the center is blank, that is actually an OR compound inequality. ORs are not written together like what we did up here. That would be an and. And just as an example, if I were to graph this right here, let's say this number is 69 right there, and we'll go all the way up to 87. And what this inequality says is that 69 is less than or equal to, so it'd be a solid dot, and then x is less than or equal to 87, but the x is sandwiched in between. And so you would get a graph that looks like this. That's an and graph. Those types of graphs can be written together like what you see me just put a star beside. Or graphs, when they look like this, where you have the ends of the graph that are shaded, those cannot be written together. They're left just like what you see right here that I circled. Okay, so we have a couple more examples here. Let's take a look at this one. This one says solve and graph the absolute value inequality. It's going to be solved the same way. We're going to have 3n plus 6 is greater than or equal to 12. Or we're going to have 3n plus 6 is less than or equal to negative 12. So we're going to subtract 6 from both sides. 3n is greater than or equal to 6. We divide by 3. N is greater than or equal to 2. Going to subtract 6 on both sides here. 3n less than or equal to negative 18. When I divide by 3, n is less than or equal to negative 6. So there again, this is going to be an OR graph. And you'll see whenever I go to graph it why it doesn't get combined. But we have a -6 right here. And then we would go 5, 4, 3, 2, 1, 0, 1, 2. There's 2 right there, 3, 4. So it says n is greater than or equal to 2. So that would be a solid dot on 2 and shaded to the right. And then the other one says n is less than or equal to -6, which would be a solid dot on -6 and shaded to the left for less than. And so again, this graph on the outside, that's an OR graph. So you would simply just leave it like this, OR. Now I'm going to skip the next one because number 8, it's pretty much the same as the last ones, and I'm going to go on to these special cases. So there are a couple instances here that we need to talk about. So let's look at this one. So this is going to be solved the same way. 4y plus 5 is greater than -3. I'm going to subtract 5 from both sides. I'm going to get 4y is greater than -8. I'm going to divide by 4, and when I do that, I get y is greater than -2. Now, this other one, 4y plus 5 is less than. Now, it already was a -3, so we're going to make it a +3 because it would be a double negative. Now, I'm going to subtract 5 here, and I get 4y is less than -2. And when I divide by 4, I get y is less than -1/2. Okay, so this first one says y is greater than -2, but it has to be less than -1/2. So let's take a look at the graph of this first to make sense of what it's telling us. So if I go here, I'm going to say this is -3, -2, -1, 0, 1, 2, like that. And then I'm going to put a red dot on -2. It's an open dot. It says y has to be greater than. So we're going to shade to the right. Now, I'm going to use a darker blue here for the other one. I don't want to do super dark blue, though. Now, the other one says y is less than -1/2, which is right here. But less than, we shade to the left. So if you look at the shading, we do have an overlapped part. So we're actually only interested in this overlapped part. And because it does overlap, this is where this is not an or, this is an and. So we are able to write this. Now we got to flip over the one with the smallest number. So it's going to be -2 is less than y. And then you can see next, y is less than -1/2. And so that's what we end up with. -2 is less than y, which is less than -1/2. And there's our and. Okay. Number 10 is done the exact same way. So there you go. That's a special case. The reason why that was a special case is that this number over here was already negative, and therefore it stayed negative in the first expression we rewrote. But then when we rewrote the second part, when you have a double negative on the 3, it actually becomes a +3. So there you go. I hope that made sense. As always, if you have any questions, feel free to email me. Have a good day.